in this video, we're going to go over how do we calculate a confidence interval for a population mean whenever the population standard deviation is unknown. All right, so in the last video, we went over how to do a confidence interval for a population mean when the standard deviation was known. And so what we ended up using was the z distribution. We had to calculate a z-score, and from that we were able to calculate the confidence interval. Well, now whenever you do not know your population standard deviation, you're going to have to use something that's called the t-distribution. And so the t-distribution looks like the normal distribution, but it has an important distinction. And the important thing is that it is based off of something called the degrees of freedom. The degrees of freedom for a t-distribution is just simply your sample size minus 1. And essentially what that means is that as your sample size gets larger and larger, this t-distribution becomes more and more similar to a normal distribution. Okay? But other than that, everything else is the same as we discussed in the previous video. To get your, remember your confidence level, and then 1 minus that was your alpha, that's still the case, and you still want to divide that by 2 whenever you're trying to find the correct t-score to use. So t-score is the t-distribution version of a z-score. All right, so as you can see here, once you have your table, you take your alpha, the remaining stuff outside of your confidence level, and you divide that by 2, and then you go to the correct degrees of freedom, and that's how you determine your t-score. Let's do a couple of examples. All right, so suppose that the individual times it takes for a running team to run a mile is normally distributed with an unknown mean and standard deviation. So we know the distribution is kind of normal, but we don't know the standard deviation. The times of 11 runners are used to estimate the mean time of the team. What t-score will be used to find the 90% confidence interval for the population mean time? All right, so a lot of information here. What's most important here is that we do not know the standard deviation, so we have to use the t-distribution. The degrees of freedom for this will be your sample size. In our case, our sample size is 11, so we're going to take 11 minus 1. So that's where we get degrees of freedom of 10. Degrees of freedom is n minus 1. Okay, and then our confidence level is 90%, so that means that alpha is 1 minus 0.90 or 0.10. which indicates that alpha over 2, which is really what we want, is 0.05. So if I take that alpha divided by 2, we get a 0.05. So that's all the information we need. So the t-score here should be, you go down the degrees of freedom row, you're going to go down to where degrees of freedom is 10. And you're going to go to where it says t sub 0.05, because that was our alpha, and the answer should be, or the answer is a 1.812. Okay, let's try that one more time. Once again, scores are normally distributed with an unknown mean and standard deviation. The scores of 22 students are used to estimate the mean score. What t-score should be used to find the 95% confidence interval? Okay, we're trying to find the t-score. Once again, go through, find your degrees of freedom. Degrees of freedom for this should be 22 minus 1, so that gives us a degrees of freedom of 21. Alpha, so if the confidence level is 95%, that means that alpha is a 0.05, which indicates that alpha over 2 is a 0.025. Okay, so I took a 0.05 divided by 2. Alpha over 2 is a 0.025. So we're looking for the t-score that has degrees of freedom of 21, and it's t sub 0.025. The answer is 2.080. All right, so as I said before, it's very similar to what we did before in the last videos. It's just now we have that extra step of finding the degrees of freedom. Okay, so bringing this all together, how do we find a confidence interval for the population mean? So it's just like what we did last video. Okay, what you do is you take your sample mean and you both subtract and add that margin of error. Remember, they like to use error-bound mean, but that's just your margin of error. Well, what is your margin of error? Your margin of error, or the error-bound mean, is that t-score that we just practiced on how to calculate, multiplied by S is your sample standard deviation. It's probably been a while since we talked about that, but S is your sample standard deviation, and N is your sample size. Okay, so if you go back and actually compare this formula to the formula from the last video, when we did when we knew the population standard deviation, it was a Z alpha over 2 times sigma over the square root of N. So all we did was replace the Z with T and the population standard deviation with the sample standard deviation. Okay, we'll do a couple quick examples of those, and that should wrap this up. Okay, Dr. Lasso performs a study to determine how effective acupuncture is in relieving pain. He measures sensory rates for a random sample of 20 patients. Suppose that sensory rates are normally distributed with a sample mean of 9 and sample standard deviation of 1.6. Very important here. We know the sample standard deviation. We do not know the population standard deviation. So this entire, section video is all about whenever the population standard deviation is unknown. Okay, so it's a key distinction. All right. But we know the sample standard deviation. Construct a 90% confidence interval. Okay, so here we go. Let's see if I can squeeze this in here. So as we know, we have to calculate our margin of error, or AKA the error bound mean. And the way we do that is we need to figure out the t-score. Well, let's see here. Our degrees of freedom will be our sample size of 20 minus 1. So our degrees of freedom is 19. And the confidence level is 90. So that means that alpha is a 0.10, which indicates that alpha over 2 is a 0.05, right? So doing what we did before, we get the t-score of, let's see, we go down to the degrees of freedom of 19. We go over to t of 0.05, and our z-score, or excuse me, our t-score is 1.729. With that being said, our error-bound mean, or the margin of error, is we take our t-score, which is 1.729, times our sample standard deviation, okay, which is 1.6, divided by the square root of 20. Okay, let's put that in the calculator and see what that value is. Let's see, 1.729 times, parentheses, times what? Times, it was 1.6 divided by the square root of 20. Actually, let me clear that up real quick. So let's put this all in one single set of parentheses. 1.6 divided by the square root of 20. All right, closing that up, and this will give us our error-bound mean, or the margin of error. To 3 decimal places, I'll do a 0.619. 0.619. So to do that, we are going to take our now we got an error-bound mean, which the total was 9. Now we're subtract away, that margin of error, aka the error-bound mean of 0.619. That will give us our lower bound of our confidence interval. Our upper bound will be 9 plus that same 0.619. Okay. Working that out, that'll give us a confidence interval of, let's see, that should be at 8.381. Will be our lower bound up to a upper bound of 9.619. So as before, in the last video, the interpretations are the same. We are 95% confident that that population mean is somewhere between those two values. All right, hope this video helps you guys out.